So I passed back the last test.
Yeah.
It was basically either you knew what you did or knew what to do, or you had no clue, was kind of the distribution. I didn't think that should have been that hard. It was basically the exact same thing as the study guide. I don't know, let me think on it for a couple of days more here. We'll talk about what, if anything, we'll do with this. I remind everyone that there is the retake test option. If we decide, not to do anything, that retake is capped at 85%. Be basically just like another version of what you just, what the test was. And that usually would be happening near the end of the semester. So for seniors, probably in April, the juniors, in May at some point. Today, I want to talk about what we've been working on. So what we've been talking about are rational functions and kind of how to find the key features of these, right? I think last time I assigned 1 through something or another. What was the number? 24. So Gabby asked about number 4, did you say? 3. Let's grab that. Oh yeah, that's a typo, Gabby.
Oh, okay.
Yeah, it should just be like x squared.
Okay.
Yeah, that's fine.
Never mind.
Never mind then. Okay, that's fair. All right. Let's just start with a couple of examples. We're going to find all the key features for these examples, and then move into the next phase of this, okay? Yay or nay?
Yay.
Yay? Okay. Oops. These, by the way, will be like complicated examples because I'm trying to squeeze in like most of the key features popping up in a meaningful way for them. All right, when we say the key features, we want domain, vertical asymptotes, and then removable discontinuities or holes. We want we're going to want HA or OA. We're going to want X/Y intercepts. And then we're going to want end behaviors. So those are the 8 key features that we're going to be looking at and coming up with. Everybody's good with the plan? So I'm going to color code the stuff. So when I do domain, vertical asymptote, removable discontinuity, I'm going to use red, and horizontal and other asymptote will do blue, and so on and so forth. Everybody okay? So that's what the color change is about. For domain vertical asymptote removable discontinuity, the first step would be to factor. Okay? So, start with the denominator. That should be easy to factor. How does x squared minus 4 factor?
X equals 2x minus 2.
Great. Now, how would I factor x cubed minus 2x squared plus x minus 2?
Take off the x's
X
first.
squared. X minus 2, x minus 2.
Okay. Polynomial, right? Was there a greatest common factor? No. How many terms did it have? 4. Should check to see if I can factor by grouping. If I can't, then we have to do the synthetic division stuff. Hopefully we can factor by grouping, right? Oops, that's the wrong button. Okay. So let's just do this off to the side here. So when I do my factor by grouping, typically I'm going to want to group it this way. Always has to have what symbol in between the two groups? Plus. There's a subtraction symbol, you just make it plus a negative and you take the negative into the group, right? What's the greatest common factor in the first group?
X squared.
X squared. The greatest common factor in the second group?
1.
1. Notice now that each of these are 2 terms. There's a common factor between the 2 terms. That common factor is?
X minus 2.
X minus 2. And my leftovers are? Oh, no, Mr. Kulik, you boogered it up. Gosh dang it. What did I need to do? It's too late now. It is what it is. We got this. That's fine. Okay. Then I should check to see if I can factor either of these anymore. Can I factor either of these anymore?
No.
No, right? Why can't I factor x squared plus 1? Is it x minus 1, x plus 1?
It's not X squared minus 1.
Oh, it's not a difference. Well, isn't it just x plus 1 squared? Doesn't that factor that? No, right? X plus 1 squared is x squared plus 2x plus 1. You have to FOIL that out. Can't distribute the exponents. Oh, okay. So I'm done then, right? All right. So I factored it. Stop, do the domain. How do I do the domain? Set the unreduced denominator equal to 0. Or I should say not equal to 0, right? Because we can't have 0 denominators. Okay. So I find that the values of x that my domain cannot contain are -2 and +2, right? Let's write that domain using interval notation. We want everything except for -2 and everything except for +2. How do I do that?
Negative infinity to union. Negative 2, positive 2. U 2.
Perfect. Questions on how I cooked up that domain? Everything less than -2, everything between -2 and +2, everything bigger than +2. That's everything except for -2 and +2. Everybody feel okay? Okay. Now, we're going to reduce Because we reduced, what can happen? Because we're able to reduce, what can happen? Removable discontinuity, the RD or the whole. Do I get one? Yes, right? Because what happened? The x minus 2 was completely reduced from the denominator. So I'm going to take that completely reduced piece, set it equal to 0 and solve. So remember, the rule of discontinuity is a point. That's my x coordinate. How do I get the y coordinate?
You plug in that
Into the reduced version. Yeah. So my removable discontinuity is 2, 5 fourths. So far, so good. The last piece I need is the vertical asymptote. How do I find the vertical asymptote? The reduced denominator set equal to 0. So as my check, the values that my domain cannot contain need to be either vertical asymptotes or removable discontinuities. They can't be both. Right? -2 can't be both a removable discontinuity and a vertical asymptote. One or the other. That's all you get. Are you okay? All right. Questions on these 3 key features? Notice that all 3 of these key features have to do with setting some part of the denominator equal to 0, right? Just whether it's before fact or before reducing, what you reduced, or after reducing, it's just denominator set equal to 0. Is okay? That's why I've grouped these 3 features together. All right. The next piece is going to be the horizontal or other asymptotes. So I'm going to look at the reduced problem. Horizontal or other asymptote is an equation. It's like a y equals equation. To figure out which one it has, it can have one or the other, but never both. I need to compare the degree of the numerator with the degree of the denominator. In this case, the degree of the numerator is 2. Because we're using the reduced version, and the degree of the denominator is 1. So we are in the greater than situation, because 2 is greater than 1. The degree of the numerator is greater than the degree of the denominator. What happens when the degree of the numerator is greater than the degree of the denominator? That tells us we're in the other asymptote situation. To find the equation for that other asymptote, I need the quotient of the numerator divided by denominator. The numerator and denominator are both polynomials. There's two ways to do polynomial division, long division and synthetic division. Long division works every single time. Synthetic division only works sometimes, but it's easier to use than long division. Can we use synthetic division in this case? Yes. What do I look at to conclude that?
The degree.
And I need the degree of something and something else. So I need to look at the denominator or the divisor. The degree of the divisor must be 1, and its leading coefficient also has to be 1. My denominator is x plus 2. That's degree 1 and leading coefficient 1, so I sure as heck I'm going to use synthetic division. Everybody's okay? So to set up my, set up my synthetic division, I take x plus 2, I set that equal to 0 and solve. That's the number for the outside. Mm-hmm. And then I'll write the coefficients from the numerator, and that's the inside. I made a mistake. Who sees the mistake? I did on purpose.
You didn't include an x value, like a 0.
Exactly right. Notice that my polynomial on top, the numerator, x squared plus 0x plus 1. Gotta have that 0 there, guys. If you forget it, you're toast. Unrecoverable mistake.
Wait, why is the 0 there?
It's filling the x's spot. I have x squared, and I have 0 x's, and then a 1.
Okay.
Okay, let's rock and roll. Oops. Everybody good with division? Real fast, right? Okay, so remember, starting at the far right, we have remainder, constant term, x coefficient. This part is my quotient, so my other asymptote is y equals at 1x minus 2. Does the remainder tell me anything about the other asymptote?
Mm-hmm.
Not even a little bit. Do I care at all about the remainder? As long as it's not 0, right? If it's 0, then it's a different story. But like, you would have caught a 0 remainder when we did the reducing, and you just would have left with no denominator at all. Yeah, you absolutely. So far, so good. Keep on going. Okay. Next up are the x and y intercepts. So again, I'm looking at the reduced version. So for the x-int, y is 0. And we're finding x. So here we have a fraction that's equal to 0. When is a fraction equal to 0?
No.
No, it can be 0.
When it's 0, 0.
And the numerator is 0.
When the numerator is 0. Okay. So is the numerator equal to 0? How are we going to solve x squared plus 1 equal to 0?
Just move the 1 to the other side.
Okay, subtract 1 and then what?
Square root of it.
Okay. When we square root both sides of an equation, what do we have to remember?
Plus minus.
Yes. What's the square root of negative 1? I. What does that tell me about the presence of x-intercepts?
Plus minus I. Or it's imaginary.
Oh, the conjugate. Oh, wait a minute.
There aren't any. Right? An x-intercept is where the graph, where the line crosses the x-axis, right? Where are the imaginary numbers at on the x-axis? They're not on there! Oh, okay. So because I got an imaginary result, that just tells me that I don't have any x-intercepts. Okay, that's fine, whatever. Mr. Kulik meant for that to be x squared minus 1, so that you can have some x-intercepts. But sometimes when you make the problem up in your head inside of 2 seconds, you drop a negative sign somewhere and you make a little mistake. And all that. That's fine, because that's a good result too, because that sometimes is confusing for students. Like, what the heck do I do with this? Well, they're just hard paying. That's okay. For the y-intercept, here we just plug 0 in for x. That's the easiest thing we do. So I just plug 0 in for x into my reduced equation and simplify down and get a half. So it's 0 comma half. Right? X is 0. That's what we plugged in, so the x coordinate is 0. Y is 1/2. That's what we found. So the y coordinate is 1/2. No big deal. We're done. That's the easiest part. Right? So my last piece are the end behaviors. So let's think about the arrows that we're going to have on our graph. Our graph is always going to have at least 2 end behaviors, right? One as x goes to negative infinity, one as x goes to positive infinity. Those have to be there. Okay? Where else am I going to get arrows at on my graph? It's also going to happen at the vertical asymptotes. Okay, how many vertical asymptotes did I have? Let's go back and look. We had 1 vertical asymptote. How many arrows am I going to get at a vertical asymptote? 2. 1 on each side, right? Everybody's okay? So how do I write that then? I'm going to need the left side of the asymptote and the right side of the asymptote. Always 2 end behaviors per asymptote. Always have the far ends. So I'm always going to have the x goes to negative infinity, always have the x goes to positive infinity. Then I'm going to have 2 more end behaviors for each vertical asymptote that I have. So if I had 6 vertical asymptotes, I have 14 end behaviors to write. 2 for each one of the 6 vertical asymptotes, and then 1 at negative infinity and 1 at positive infinity for a total of 14 end behaviors to write. Mr. Kulik, you're not going to do that to me, and the answer is no. Right. Probably never see more than 2 vertical asymptotes in the problem. Which is still how many end behaviors if I have 2 vertical asymptotes? Well, total 6. Right? 4 from the asymptotes, and then 1 at either end. So 6 total. Does everybody feel okay here? Okay. So, remember our function is y equals x squared plus 1 over x plus 2. Okay. So I'm going to imagine what's going to happen if I plug a very big negative number in. A negative squared is going to give me a positive. And adding 1 to the positive is going to make a still positive, right? Very small negative number, like negative 1,000 on bottom. If I add 2 to that, what kind of number do I have on bottom? Negative. So as this gets more negative, the y is going to get more negative, right? So going to negative infinity. Is everybody okay with that idea? So now let's think about plugging a big positive number in here. If I plug a positive on top, I get positive plus 1, still positive, over positive plus positive. It's all still positive, right? Now, important to note, let's go back. I'm gonna put a little asterisk here because I want to come back and mention this here for just a second. I know people are writing. I'm gonna just, there's a reminder for me to stop and explain a little bit more. I don't like the way I explain this. Okay? This piece, don't do it the way I just said. That was a dumb way of describing it. Do this instead. This is easier. I go back and I look at my other, or my slant or horizontal asymptote, or my other asymptote or horizontal asymptote. If I have another asymptote, my end behaviors at the end, my positive, negative, infinity ones, are either going to go to positive infinity or negative infinity. I can tell just by the end behavior of this. This positive slope. So when it goes to positive infinity, we go to positive infinity, negative infinity, negative infinity. Everybody's okay? If this was a horizontal asymptote, like y equals 5, these are just going to be both 5. So what I really want to say here is, so really how I'm doing that is I'm using the value of the horizontal asymptote, or if I have an other asymptote, just kind of the slope, whether it's positive or negative. So positive slope, positive infinity goes with positive infinity, negative goes with negative. If it's a negative slope, it just flips, right? Negative infinity goes with positive infinity, and positive infinity goes with negative infinity. Does that feel okay? Okay. So now let's think about these guys. So here I'm approaching, now I'm going to do it the way that I intended. So here I want a value to the left of negative 2. So let's say like negative 1.9. A negative squared is a positive. Negative 1.9 plus 2 is positive. Positive over positive is positive. So that's going to be positive infinity. Your end behaviors from your vertical asymptotes are always going to either be positive or negative infinity, every single time. It's only the end behaviors going to positive or negative infinity that could be finite values, but they weren't in this case. If I pick a number to the right, oh my God, guys, Mr. Kool-Aid, we're so stinking dumb. Negative 1.9, is that to the left of negative 2? On the number line? We did this one. I put it in the wrong spot. Great Googling, Mr. Kool-Aid, come on now. How come none of you guys objected to me saying that negative 1.9 was the left of negative 2? Come on, guys. We can do better than that. All right. Now let's pick a number left of negative 2, like negative 2.1. Still positive on top. Right? Negative squared is still positive. Negative 2.1 plus 2 is negative. So I know it's going to be negative. Notice at no point have I gotten out a calculator to do any of this. Right? What I want to do now is I want to take all this key features together and build a graph out of it. Okay? So again, this would ostensibly be the entire, like an entire section of the test. Now, I would not have it all combined together because like one question where I ask you to do all of this stuff, if you make one mistake, like a bunch of crap afterwards is going to be wrong. but it would be like all separated out, like here's a problem, give me these features for it. Here's a new problem, give me these features from it. Here's a new problem, give me these features. Here's the features, give me the graph. So I would break this apart so that it's like less contingent that you did every single part right to get the next part right. But this would be like half of the test. It's essentially this one question. All right. So we're going to draw the graph now. Yeah, that's probably a terrible color. Let's do purple. Love me some purple. All right. So I'm going to start by plotting my asymptotes. We had one vertical asymptote at x equals -2. So when I plot a vertical asymptote, I'm going to plot a vertical dashed line that passes through the x value -2. Everybody's okay there. I have one other asymptote. That other asymptote is at y equals x minus 2. How do I, that's a line, right? How do I graph a line? What do I need? 2 points, right? How do I get 2 points on a line? Just pick some value of x's and plug them in, right? So let's plug 0 in. When I plug 0 in for y equals x minus 2, what do I get to come out? Oh my gosh, guys. -2, right? Okay. And then let's pick another value. Maybe I pick 2. Does it matter what x's I pick? No, I'm just picking stuff that's convenient. What's 2 minus 2?
0.
0. Nope. So like here and here, and I'm just kind of drawing that in. Is everybody okay with how I drew in my other asymptote? If it's horizontal, it's easy. It's just a horizontal line. The other asymptote, I had to plot some points, like, but big whoop, right? This is a pre-algebra skill of graphing a line, right? The slope is easy. I mean, it's just slope 1. Like, there's a million ways you can do it. So far, so good. Okay. I'm now going to plot the hole, right? I had a hole on my graph at 2, 1.25, 5/4. So on my graph, I'm going to graph 2 and then 1.25, and I'm going to do that as a open point. It's a hole in my graph, so the way we draw it is with an open circle, not filled. Is okay there.
Wait, where did you get the 1.25?
5/4 was the y coordinate for my removal of discontinuity. I just converted that into a decimal to make it easier to plot. Right? Where's 5/4? I don't know. Where's 1.25? Okay. All right. I didn't have any x-intercepts, but I do have a y-intercept, right? That y-intercept was 0, something, 1/2. So I have, that would be like here. Everybody's okay? So far, so good? Now I'm going to do my end behaviors. I'm going to start with the vertical asymptotes. So on the right side of my vertical asymptote, should be going to positive infinity. So I look at my vertical asymptote. On the right side, I should be pointing to positive infinity. Now that graph needs to connect to these other points, and then needs to follow the other asymptote. And notice as x goes to positive infinity, y is going to positive infinity, so we're have accomplished those two. Everybody okay there? Now let's look at the other end behavior for the vertical asymptote. So that says on the left side of -2, the arrow should be pointing down. So there. Now the graph can't cross the asymptotes, so I would just draw this similar to how I drew the other piece and just kind of connect it together. Notice that as x goes to -infinity, the y is going to -infinity, which is exactly what we say here. So what we've done is we've taken our key features and pieced them together into a graph. What do you guys think? Should we do this again? Another example? Now keep in mind, this is like half of a test, right? Like one question is like half the test. Now I would not turn it into one question where it all depends on each other, but like that's like half of this chapter right here, is the ability to find the key features and then take the key features and build a graph out of it. Okay. So let's do another one. Do that. So we're still looking for the key features, and we're still going to build the graph out of the key feature. Is it okay if I stop color coding everything? Yeah. Okay. It's just getting a little aggravating for me. Like, if you guys are good, and the first time I think it's helpful to like color code it so you can see what we're doing. The second time through, I'm just not going to do it anymore.
Fine.
Okay. So first thing we look for are domain, remove discontinuity, and vertical asymptote. We need to start by factoring. Okay, x squared plus 5x plus 6. How does that factor? This is awful slow, guys. Multiplies to give you positive 6. Adds to give you positive 5. 2 and 3. Oh boy, guys. And then how does the denominator factor?
X plus 6
X plus 4, x minus 4. Any reducing that can happen?
No.
No. What does that tell me immediately?
There's no.
No removable discontinuity, no RD. Exactly right. Okay, well, we still do the domain, right? Take that denominator, set it not equal to 0. So x can't be 4 or negative 4. How do I write the domain then? The interval from negative infinity to
-4.
negative 4, or
-4, 4.
negative 4 to 4, or
4 to +1.
perfect. Okay, no removal of discontinuity, we mentioned that already, and why?
Because you can't reduce the denominator.
Correct, because there's no reducing from the denominator, so no removal, discontinuity was created. What are the vertical asymptotes here?
X plus 4. -4, 4.
Yes. Right? All the things that aren't in the domain have to be either a vertical asymptote or a removal of discontinuity. If there's no removal of discontinuity, those both have to be vertical asymptotes. And notice they are equals for asymptotes and not equals as part of the domain. So far, so good? All right. Let's look at now the HA or other asymptote. To do that, what do I need to compare?
If the numerator is greater than the denominator.
Yeah, I have to look at the degrees of the numerator and denominator. What's the degree of the numerator? Nope.
Oh, it's
2. 2. And the denominator is?
2.
2. Since they're equal, what happens?
divided by leading coefficient.
Leading coefficient divided by leading coefficient. What's the leading coefficient in the numerator?
1,
And the denominator?
1,
So the horizontal asymptote is
1.
y equals 1. Again, have to have it as an equation. It has to be y equals. I know what you mean, but like, we'll be picky about it. I'm letting you know that I'll be picky about it. Right? We have to have the y equals in front. Just like for the vertical asymptotes, we have to have x equals. Those are equations, not numbers. But I know what you mean. So far, so good? All right. Let's do x-intercepts next. How do I find the x-intercept?
Y equals 0.
Great. Which means that I'm just going to be, in reality, setting the numerator equal to 0, right? Since it's one fraction. Notice that I'm using the factored form to do this. Once I factor, I'm pretty much using that exclusively throughout, other than maybe like the horizontal or other asymptote piece. I guess I look at the original there. But okay, what are my two x-intercepts then?
-2 and -3.
-2 and -3, but I need to write them as points. I don't want to confuse them with a vertical asymptote. So I want to make sure I'm writing them as an ordered pair, not as a number. Everybody feel okay there? Is the y-coordinate always 0? Yeah. Why is it always 0? What do we plug in for y to solve this? 0 in for y, right? Y-intercept, how do we find that?
Set all the x equals 0.
Yep, plug 0 in for x's.
Does that include the denominator too?
Yep. So there we have the point 0, 3/8. Again, remember, x and y intercepts are points. They're ordered pairs. They're not x equals y equals. I don't want to confuse it with a vertical asymptote or horizontal asymptote. I need to make sure I'm writing it as an ordered pair.
Why for the x is it only the numerator that you plug in here?
Because the only place a fraction can be 0 is if the numerator is 0.
Oh.
The denominator does not matter, right? 0 over 2, 0. 0 over 3, 0. 0 over 5, 0. 1 over 0, undefined, not 0. That's why. Does that make sense?
Yeah.
All right. So these are everything but the end behaviors now, right? Let's zoom back in. I'm going to start a new column here because that was getting a little wide. How many end behaviors am I going to need?
6.
6 total. 2 at the ends, 4 for the vertical asymptotes. So the left end, that's the right end, and then I'm going to have, I'll just go across this way. The left side of the first vertical asymptote, and the right side, and then the left side of the second vertical asymptote. And the right side of the second vertical asymptote. So that much I can guarantee to write. Shouldn't make a mistake there. All I'm doing is copying down, like left end, right end, left side, right side of the first vertical asymptote, left side, right side of the second vertical asymptote. Now I could make a mistake on the other parts, that's fine, I can accept that, but like here I should definitely have the right answers. Or should be able to get this much on my paper. That's like half credit right there. Just have that much of the notation down. You know what I mean? Didn't see a lot of limits on the last end behavior question. I hope to see better limiting this time. Okay. So the left end and the right end, I'm going to get by looking at my answer for the horizontal or other asymptote. Since I have a horizontal asymptote, what are the left end and right end behaviors going to be? Same as the horizontal asymptote.
Positive.
Yep. Everybody's okay? If it's a horizontal asymptote, it doesn't matter if you're going to positive or negative infinity, it's just the value of the horizontal asymptote. If it's the oblique or the slant asymptote, where it's y equals, if it's positive slope, it's the same as what x is going to. If it's a negative slope, it's opposite. Let's look at approaching -4. If we're going from the left, a value less than -4 would be like -4.1, right? If I plug -4.1 in here, I get negative times negative over negative times negative, which is all positives. So positive infinity. If I plug in a value to the right that's bigger than -4, say -3.9, positive, negative, 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 which is a negative. So negative infinity. So doing okay? So now we'll pick a value less than negative or than +4, so like 3.9. So positive, negative, positive, positive, negative. And then I pick a value bigger than 4, say 4.1, positive, 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 positive. Is anybody other than Addie understanding what I'm doing here? She answered all of those. I just want to make sure. It's okay? And again, I'm trying to keep it simple. Like, we don't actually need to compute any numbers here. We can just look at signs, right? That's enough for us. Because in all reality, I'd like to be able to do this with no calculator at all. just looking at positive and negative, and that's enough for me.
Are we gonna do one more of those? Not the whole problem, but the end behavior?
Well, we're going to draw the graph of this right now,
Okay.
and then we'll see where we're at, okay?
Okay, I'd like to do one more.
Okay. So let's draw the graph now. And I should say that technically what we're doing is sketching the graph, because we're not actually, like, we're just getting the key features connected, but like what's happening in between the key features, who the heck knows? All right. What do I need to do? What's the first thing I draw in? Asymptotes. So I have a vertical asymptote at -4. And at +4, and then at y = 1, is everybody so far so good? Look good? Next, I'm going to plot the removal of discontinuity. Oh, there wasn't one. Done with that. Now I'm going to plot the x and y intercepts. The x-intercepts were at -2 and -3. And the y-intercept was at -3/8. So, like, maybe here.
Are those the ones that are the open circle?
Nope, the removable is the open. The intercepts are always solid.
Okay.
So far, so good?
Yeah.
I'm going to draw in my end behaviors now. I start with my asymptotes. The left side of -4 is positive infinity. The right side of -4 is negative infinity. The left side of -4 is negative infinity. And the right side of -4 is positive infinity. Is everybody okay with how I drew in those arrows? Now I'm going to connect the pieces on the middle here, because I have some points that those are going to go through. Let's do that a little bit better. And do something like that. Is everybody okay there? Okay, notice that I don't cross the asymptote unless I have to. Right? Sometimes in the middle it has to be crossed because you get like this one up here or something. Now, to draw the rest of this, I know that my end, I'm not supposed to cross the asymptote. So this is just going to kind of have to come down like this. And this one's going to have to come down like this. And that'll be my graph. Contains all my key features. Notice I did this without a calculator. Totally doable. How are you guys feeling on this? Right? Again, the individual pieces, finding individual pieces, nothing is complicated, right?
No, that's fine.
Everything is reasonably simple, but you got to keep track of like how to do each piece. That's the part that's hard, is there's like 8 things to do. Got to keep track of how we do each thing. Okay.
So, like, everything as far as, like, finding the domains and everything, that's all just, like, going to be a singular thing, like, on the test? Like, we don't have to, it's not gonna be like one big problem where we have to find everything for one single problem.
I probably wouldn't structure it that way because it makes, like if you do the factoring wrong or something, everything is wrong afterwards, which is kind of dumb, right? Like, I would, you know, and it might even be a situation where it's like, here's the factored form. I've given that to you already, so you can't muck that part up.
Yeah.
You know, like, do it from here. Because what I want to find is not, can you factor or not, but can you do this part of it? Now I think like one problem where I ask you to do like the whole thing, where it's relatively easy, is reasonable, but like something where it's complicated to do the whole thing is, you know, that very first one we did where it was like you had to do the polynomial division, you had to factor a cubic, and like that was harder than something I would ask you to do all of, for sure. All right. Hannah, you had wanted to do another end behavior example, right? Okay. Let's do one more. All right, so I'm just going to write the answer in like a factored form. I'm going to write the problem in a factored form just to make our lives a little easier. Is that okay? That's fine. Okay. So for us to do the end behavior, we need the information about the asymptotes, right? And we need the information about the, just the information about the asymptotes, right? That'll be enough. Since there's no reducing that can happen, and I know that because I wrote it in the factored form. What are my vertical asymptotes going to be? No.
X plus 2, X minus 3.
X equals 2 and X equals negative 3. Just set the denominator equal to 0 and solve. Is everybody okay there?
It's always going to be only the denominator.
Yeah, as long as it's reduced. Reduced denominator, we should say, but like we just mentioned that there's no reducing. Does this have a HA or an OA? What do I need to compare?
If the numerator is greater than the denominator?
The degree of the numerator and the degree of the denominator. What's the degree in the numerator? 2, because we have x times x up there, right? The degree in the denominator is 2, because we have x times x down there. So are we going to have a horizontal, an HA or OA? HA, good. So it's going to be y equals, and then what's the formula for that HA since the degrees are equal? Leading coefficient divided by leading coefficient. The leading coefficient on top is 2, and on bottom it's going to be 1. So we have y equals 2. Why is it? So the leading coefficient on top is 2 because you're going to have 2x times x. That's going to be the x squared term, so it's a 2x squared. On the bottom, the leading coefficient is 1 because the biggest term is going to be x times x. That's 1x squared.
All right.
Feel good? Again, you would have had the the non-factored version, but like, just don't want to foil it out in my head at this point. I'm kind of tired. Okay, so we needed this to be able to set up our end behaviors. How many end behaviors are we going to get here? 6. Try writing out the start of the 6. And I'm going to be filling in behind you, and you can check when I'm done. You don't need to write what they are equal to, but just kind of write the setups, right? And technically, the order doesn't really matter. So as long as you have them down here somewhere, that's fine. I usually think it's easier to try to write them in a sensible order. But, you know, like, if you're not a sensible order kind of person, you're just like, I just need to get them down here somewhere. Like, I get it. So again, I wrote the left end, right end, and then the left and right side for each asymptote, right? Okay. To fill in the left end and right end, what do I need to look at? The HA or OA. Since it's a horizontal asymptote,
Oh, HA?
what are the end behaviors here?
2.
2 for both.
Oh, hi there, Mr. Doctor.
Oh, hi there.
Okay, look at how, okay, so it's confidence to diagram, right?
Yes.
This matches that. This kind of matches that. And you're a dude, so I made sure to grab the black one because.
I just usually use them to put my daughter's marker in two places.
Okay, so which one would Sloan like?
She likes black.
Okay.
I'll take
Mr. Stevie?
Very good. What? What?
I didn't do it.
Oh, I don't know. I'll give you guys the first one.
So far, so good?
Why would the first one read the negative infinity and positive infinity? Why is it the 2 in that spot?
So the left end and right end of the graph are always dictated by the horizontal or other asymptote. Okay? If it's just a horizontal asymptote, y equals the number, that's the spot for each of these. Because if you think about the graph, like there's a horizontal asymptote, you know, the graph is going to do something like this and just follow the asymptote at the ends, right? Left end, right end has to be following the asymptote. Is that? All right. So now we pick a value that's less than -3. So like -3.1. If I plug that in up here, negative, 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 negative. 4 negatives is positive, right? If you have an even number of negatives, it's positive. Okay? Now I need a value that's on the right side of -3, say -2.9. Negative, 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 positive. 3 negatives is
Negative.
negative.
Yes.
Okay? Now I'll pick a value on the left side of 2. So like 1.9. Positive, positive, negative, positive. 1 negative is negative. Right? It's an odd number of negatives is negative. Even number of negatives is positive.
Okay, yes.
And then something to the right of 2, say 2.1. Positive, 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 positive.
Negative.
Positive.
That's an even number of negatives because it's 0, so it's positive. Or all positives, you should just positive. Right?
Okay, got it.
There you go. Does that feel?
That feels better, yeah.
Yeah. I am Hadooped. I don't know about you guys. That was a lot of math in there we did. Good job hanging in there for it. I'm going to add, let me just double check here. 0 problems to the 1 through 24. Yay! Your virtual day assignment for Thursday will be a Delta Math for chapter 14. It's already in there. If you wanted to start early, you can start early. But like that's your virtual day assignment is the chapter 14 Delta Math assignment. Doing just these skills, like finding the key features and drawing a graph or whatever. It's just like this fun stuff. Sound good?
Yeah.
Any questions about anything we did today? Who feels better about finding these features? Who's like, I'm gonna put the smackdown on this test coming up. Yeah, get it.
Can you raise your hand? Sure. I raised my hand for the first one.
Raise your hand once again.
Yes. I actually am so curious. What is this one?